Within a species, at any one point in time, there may be several different populations. These will show patterns of interbreeding within and across populations. One of the ways genetic divergence leading to speciation begins is as one population of the species becomes physically separated from other populations. If this occurs for a significant amount of time, with the amount of time varying across different groups, these species start to accrue independent genetic changes, and eventually this can lead to a new species with its own distinct evolutionary history and tendencies. However, just because genetic divergence can lead to speciation does not mean that genetic divergence always leads to speciation. In fact, genetic divergence can happen without speciation. Furthermore, there is no set amount of genetic divergence always associated with speciation. Sometimes the amount of genetic change can be more substantial. Other times it can be relatively minor. What Eldredge and Gould predicted with Punctuated is that genetic divergence will be concentrated at and around speciation, a notion validated by Mark Pagel and Chris Venditti and others. Some of the shortcomings of the old perspective on speciation, epitomized by the Neo-Darwinian synthesis, was that it viewed speciation as solely associated with the transformation of one species to another, and it treated speciation solely as a matter of the gradual accumulation of genetic divergence in the absence of geographic isolation. One of the reasons Eldredge and Gould developed Punctuated was that they recognized the importance of allopatric speciation to macroevolution. Speciation was not just about transformation, but about the generation of new diversity.